Hi everyone, in this video we look at finding the vertex of a quadratic function by partial factoring. So, if we think about just a generic parabola that's graphed on the Cartesian grid, well, let's think about what points this parabola have. We already looked at that the fact that if you have a parabola, it is written in, you can write it in the form, all parabolas that is, f of x is equal to ax squared plus bx plus c. Now, if we compute f of 0, that gives us c. Because I'd have a times 0 squared plus b times 0, which is just equal to c. That gives us a point on our graph. That gives us this point right here. That point is 0, comma, c. Now, if this point is not the vertex, that gives us another, if we, there's another corresponding point on this parabola that has the x value, x1, and it has the y value, c. It has the same y value. So if we know these 2 points, if we know the x values of these 2 points, we can simply add up the x values, divide by 2, that would give us the x value of the vertex. And that would be this coordinate right here. That would be the x value of the vertex. In order to get the y value, we just compute f of xv in order to get the y value of the vertex. So this, when we use this method algebraically to get when we actually go through this method, and I'm going to show you how to do that in a second, this method is called partial factoring. So let's look at a question where we're asked to use partial factoring to find the vertex of the function y is equal to 4x squared minus 5x plus 1. And I'm going to change this example just so that I'm using function notation. So I've got f of x is equal to 4x squared minus 5x plus 1. So in order to go through this process, I'm going to let my y value be equal to c. And then I'm going to solve for my 2 x values. Now I should get one x value that's equal to 0, and then I should get another x value. So let's let my y value, which is f of x, be equal to c. Now c here is just the constant term, which is just 1. So I'm going to let f of x be equal to 1, and I know that that's equal to, let's write this on a separate line just to have good math form. So we're going to let f of x be equal to 1, and that is that 1 is equal to 4x squared minus 5x plus 1. Now I can solve this equation. If I subtract 1 from both sides of the equation, I get that 0 is equal to 4x squared minus 5x. I can common factor in order to solve this equation. Both of these terms have a common factor of x. So I'll common factor out x, and I get x times 4x minus 5 is equal to 0. Now, in order to solve this equation, I can say what values of x make the left side equal to the right side. So one value for x is when x is equal to the 0, or when x is equal to 0, because 0 times whatever number this is would be equal to 0, and that would make the left side of the equation equal to the right side. Now the other possibility is that 4x minus 5 is equal to 0. If 4x minus 5 is equal to 0, then x would be equal to 5 over 4. Now if you're not sure why that's true, well, solve the equation 4x minus 5 is equal to 0. You can add 5 to both sides of the equation, so you get 4x is equal to 5, and divide both sides by 4, so you'd get x is equal to 5 over 4. So the two solutions are x is equal to 0 and x is equal to 5 over 4. Now, those are the 2 x values with a y value of 1. So we have the points on this parabola that I've got up here. This point would be 0, 0, 0, 1, And this other corresponding point would be 5 over 4 comma 1, because I let y be equal to 1, and then solve for the corresponding values for x. So the next thing that I have to do is I have to get the x value of my vertex. To do that, I'm going to add these two values up and divide by 2, because my vertex, my x value of my vertex is exactly halfway between these two x values. So I'll write x subscript v is equal to 0 plus 5 over 4 divided by 2. Now this is equal to 5 over 4. Division by 2 is the same thing as multiplication by a half. So 5 over 4 divided by 2 is the same thing as 5 over 4 times 1/2, which is just equal to 5 over 8. So that's the x value of my vertex. Now to get the y value of the vertex, I simply plug 5 over 8 into my function. So I do f of 5 over 8 is equal to 4 times 5 over 8 squared minus 5 times 5 over 8 plus 1. We can go ahead and we can square 5 over 8, so we get 4 times 25 over 64 minus 25 over 8 plus 1. We can do some dividing out here. 4 goes into 64 exactly 16 times. So this simplifies to 25 over 16. In the same step, I can rewrite these all with a common denominator. I can rewrite negative 25 over 8 as minus 50 over 16 plus 16 over 16. So I've got 25 over 16 minus 50 over 16, which gives me negative 25 over 16. Negative 25 over 16 plus 16 over 16 is going to give me negative 9 over 16. And remember that this is the y value of my vertex. So therefore, the vertex is located at 5 over 8 comma negative 9 over 16. And we've solved for the vertex. So that concludes this video, and we'll see you in the next lesson.